The features are the results of the convolutions. Okay, the features that we have in the feature extraction layer, they are the result of the convolution operation. Okay, and in the convolution operation, I said that we have a kernel or a filter. This kernel or filter, it is a matrix, and this is the input. The input is a matrix. I said that the input image that we have, it is like a matrix. The image is like a matrix. Okay, and when we move this kernel on the input, I said that we put the center of the kernel. Okay, this is the center of the kernel. We put it in this input and we move it, and in each position that we are moving it, it gives us some output. These are the outputs. These outputs are the features. The features that I said, the feature extraction, these are the outputs of the convolution. Okay, I talked about convolution in the previous session, and I said uh, in the convolution we are multiplying each of the items together. Okay, and then we are adding them up to each other. Okay, and this number in this slide, this number 4, it is the result of the convolution that we put it here. Okay, so that's what happens in the convolution layer. Okay, we have some of these kernels. Okay, as I said in the previous session, I said that in the convolution layer, okay, in the convolution layer we have some neurons like the MLP, okay, like the MLP, the multi-layer perceptron. In the convolution layer we have some neurons, and each neuron is a kernel, a filter. Okay, this kernel, this kernel, okay, this kernel. Each of the neurons is a kernel. Okay, each of the neurons is a kernel. So in the convolution layer, we are doing multiple convolutions on the inputs. Okay, if we have an image, we do multiple convolutions on that image, and this gives us some results, some outputs. Okay, so uh, in the convolution layer we have some neurons, and each of these neurons are a kernel. Okay, this kernel, each of the neurons in the convolution layer, they are a kernel. And uh, one of the most important things about these kernels is that these kernels, they have some numbers inside them. Okay, 1 0 1. Okay, these numbers, they are learned. The learning, the learning of the CNN in the convolution layer, the weights, the weights that are learned in the convolution layer are the numbers inside these kernels. Okay, so the kernels, the numbers inside the kernels, they are modified. They are learned. They are learned. Okay. Do you remember we talked about learning in the multi-layer perceptron, and we said that each neuron, it has some inputs and some weights. Okay, in the convolution layer, the weights uh, the weights are the numbers inside these kernels, and these kernels, they are learned. Okay, do you understand this? I talked about this in the previous session. So this is the convolution layer. Okay, in the convolution layer we have some neurons, and each neuron, it has some numbers inside it, and those numbers are the weights that are being learned in that layer. Okay, and then the activation maps. These are the outputs of the convolution, and these are the features. Okay, activation map, it means the output of the convolution. Okay, when you are doing a convolution, the output is the activation map. In this slide, this is the activation map. Okay, activation map is the output of the convolution. So the activation map is the output of the convolution. Okay, for example, if we have uh, some in a convolution layer, we have 5 neurons. Okay, in a convolution layer, for example, if we have 5 neurons, it means that we have 5 filters. Filter is the same as kernel. Okay, they are synonyms. Filter is the same as kernel. If in the convolution layer we have some 5 neurons or 5 filters, okay, and then we do the convolution operation, okay, the convolution operation would have 5 outputs, 5 activation maps. These are these outputs, okay, 1, 2, 3, 4, 5, okay. These are the result of those 5 kernels. So uh, this is what happens in the convolution layer when we have multiple neurons. Okay, and okay, so we learned that in the convolution layer we have some neurons. The neurons in the convolution layer, they are the kernels, and the numbers inside the kernels, they are learned. Okay, that and uh, and when we are doing the convolution operation, we have an output. The output is called the activation map. Okay, the output is called the activation map. Okay, the output of the convolution layer, it is the features. As we said, the feature extraction in CNN is the most important thing, and those features are the output of the convolution layer. Yes, the no, the filter is not a layer. Okay, the filter it is like a neuron, not a layer. The filter is like a neuron. In the yes. Okay. Uh, in the in the CNN, in the CNN, okay, we have some hyperparameters. What do we mean by hyperparameters? Hyperparameters are some other parameters that are important in the CNN. Okay, the main parameter of the convolution layer. Okay, the main parameter of the convolution layer is the numbers inside the kernels. Those are the weights. The weights that are learned in the convolution layer are the numbers inside those kernels. okay, or filters. But besides these parameters, uh, we have some other parameters, and they are called hyperparameters. For example, the size, the size of the kernel, the size of the kernel, okay, the size of the kernel is one of the parameters. It's called a hyperparameter, okay. Okay. Uh, for example, the size of the kernel is usually an odd number. Okay, 3, 5, 7. Okay, it is usually an odd number. Do you understand? 3, 5, 7. Okay, the size of the kernel. It is usually an odd number. زوج فرد. فرد. In Farsi we say فرد. زوج فرد. زوج even, فرد odd. So the size of the kernel is an odd number. فرد. Okay. And it is always smaller than the input. It is always smaller than the input. For example, in this example you see here, the size of the input is 5 by 5, and the size of the kernel is 3 by 3. Okay, and then okay, so that's about this. So this is a parameter. This is a hyperparameter. Okay, in this example, for example, we could have the size of the kernel. It could be 3 by 3. It could be 5 by 5, and sometimes it could be 1 by 1. Okay, in some of the CNNs we have the size of the kernel is 1 by 1. Okay, so they have you may have a question that what does this mean 1 by 1. Okay, it's uh, they do this because the CNN would be smaller, the number of parameters would be smaller, and this is very important. The size of the CNN is very important. If we have a small CNN, it would work faster for us, and the learning would be faster. Okay, so in some special applications, the size of the kernels are 1 by 1 sometimes in some of the layers. Okay, so this is the size of the kernel, and uh, uh, um, the size of the kernel could be different odd numbers. Okay, uh, the one other point about the convolution layer is the number of the outputs. Okay, it's called output depth. The number of the output of a convolution layer. The number of the output depends on the number of filter or kernel that we have in the convolution layer. Okay, so the number of output depends on the number of filter or kernel that we have in the convolution layer. Okay. Uh, one other point about one other hyperparameter that we have in the convolution layer is the step of the filter. It is called a stride. A stride means the step of the filter. What does this mean? It means that, okay, this kernel that we have here, I said that in the convolution operation, this kernel uh, uh, okay, let me answer your question. You say that in the convolution you mean multiply row by row with the matrix? No, it's not like that. The convolution is not multiplying row by row. Okay, each item is multiplied. Okay, for it. Okay, look at this. Look at this figure. Okay, look at this figure. Okay? For example, okay, this is the input. Okay, this is the input, and this is the kernel. Okay, in this kernel we have 9 numbers. Okay, and here in this input, okay, let me in this input here we have 9 numbers here. Okay, okay, we have 9 numbers. So these two 9 numbers, they are multiplied in each other. Okay, as you see here, okay, these are 9 numbers, they are multiplied. These 9 numbers, they are multiplied, and then they are added up. Okay, do you understand? Miss Mrs. Russia. Okay. Okay, so each item is being multiplied to another item. Each item, okay, so we don't multiply row by row. We are uh, multiplying each item. Okay. Okay, now about this point, the filter step. What does this mean? The filter step. The filter step is no. The result is not divided by 9. Okay, Mr. Hussein, Mr. As-Sultani. Okay, the result is not divided by 9. Okay, the result is 4, and the 4 is put into that point. Yes, yes, multiplying each value of the cell by the corresponding weight. Yes, okay, thanks. Mr. Kashash, thanks. Okay, one other parameter that we have in the convolution layer is the filter step. What does filter step mean? Filter step means that when the kernel is moving on the input, what is the step of the kernel? Okay, okay, listen to this. I said that this kernel, the center of the kernel is moving on the input. Okay, for example, if the center is here, okay, this is the first point, and then the next point is here in this. The next point is here. The next point is here. Okay, here. Okay. In this uh, style, the step is 1. Okay, when the step is 1, it means that we are moving one by one. Okay, but if the step is 2, if the step is 2, what does this mean? It means that when we start from here, if the step is 2, then we go here. Okay, it means we are moving 2 columns. Yes, the center of the kernel is moving. We are moving the center of the kernel. Yes. And then it means that we put the center of the kernel at that position. Okay. Okay, we put the center of the kernel in that position. So when the step is 2, we start from here, then we go here. So we move 2 columns. And then we move 2 rows. What does this mean? It means that the next point that we will go is here. And then the last point is here. Okay? So we are only moving in 4 points. Okay, when the step is 1, we are moving in 9 different positions. But when the step is 2, in this example, we are moving in 4 different positions. Okay. Uh, okay. Do you understand about the step? So this is a hyperparameter that we have in the convolution layer, the step. Okay, so a step is important. Okay, a step is very important. Why is it important? Because it is controlling the size of the output. Okay, in this example, if the step is 1, the number of features would be 9. And if the step is 2, the number of features would be 4. Okay, so the step is important. In most of the situation, the step is 1. Most of the time, the step is 1. But sometimes the step is 2. Or we could have uh, different numbers. Okay, but usually the step is 1 or 2. And most of the time, it is 1. Okay, one other point about the CNN is 0. Okay, do you have my voice? Okay. The center, the center of the okay, we move the center of the kernel on uh, the input. Okay, we put the center of the kernel here, and then we put it here. Okay, when the step is 1. Okay, put it here. Okay. I said that we can't put the center of the kernel here. Okay, we can't put it here, or we can't put it here. Generally, we can't put the center of the kernel in the boundary. This is the boundary, okay? Boundary. Mars. Do you understand? We can't put the center of the kernel in these places. Why? Why? Because if we put the center of the kernel, for example, in here, a part of the kernel is outside the input, and then we don't have any numbers there. We don't have any numbers outside the input. Okay, do you understand this? Uh, for okay, let me uh, the out. Okay, let me write something here for you. Okay, if we put the center of the kernel here at the boundary, okay, let me write something for you. Okay, can you see what I have added to this image? Can you see what I have added to the input? Do you see these zeros I have added? Okay. If we, okay, this is called zero padding. Zero padding means that we add zeros all around the input. Okay, we add some zeros all around the input. Zero padding. Padding means adding something around to uh, something else. Okay, so here we are adding some zeros around the input. This is called zero padding. Why do we do this? Why do we do zero padding? Okay, why do we do this? We do it because if if we if we put the center of the kernel at this point, okay, then because we have zeros around the input, we could do the convolution operation in the boundaries in these points. Why? Because we have zeros around the input. Do you understand this? So zero padding means we are adding some zeros. Yes. Okay, we are in zero padding. We are adding some zeros around the input, all around the input. Okay. Here I have added 6. Okay. But I should add 1 0 here too. Okay. All around the input we have some zeros. And why do we do this? Because we want to move the kernel on all of the places of the input. If we don't have zero padding, we can only move the center of the kernel here, okay? And we can't move on the boundaries. If we want to move the center of kernel on the boundaries, okay, we should have zero padding. We should add zeros. Okay, this is what the system is doing. Okay, this is a concept, zero padding. Okay, so zero padding means we are adding some zeros to around the input, so we could move the kernel on all of the input, not just a part of it. Okay, do you understand? If we have zero padding, if we have zero padding, the size the size of the output of the convolution, the size of the output of the convolution. I mean this matrix. Okay, this is the output of the convolution. Okay, if we have zero padding, the size of the output is the same as the size of the input. But if we don't have zero padding, the size of the output is smaller than the size of the input. Okay, so zero padding has this effect on convolution. Okay, the size, the number of features would be more when we have zero padding. The number of features. This output was the features. Okay, so the size of the output is the same as the size of the input when we have zero padding. Okay, do you understand? Okay. So this was some concept about some hyperparameters in the convolution layer: filter size, the size of the output, a step, and zero padding. These are four hyperparameters that we have in the convolution layer. Okay. Uh, okay. In the convolution layer, we have uh, two different two different layers that they are doing some other operations. Okay, one of them is ReLU. This is a layer in the convolution. In the After the convolution layer, we may have a ReLU layer. Also, we may have normalization. No, after Mr. Bassett. After convolution, we have some layers. Okay, so it's not the last layer. In the feature extraction layer, okay, uh, we have different layers. One of them is convolution. Convolution is the most important layer in the feature extraction. But after convolution, we have some other layers. For example, the ReLU layer here in this slide. Okay? ReLU in the or the for example, normalization layer. Okay, if you in this slide that here you see the ReLU. This is the ReLU layer. Okay, ReLU layer. Convolution is one of the layer, and we may have multiple convolution. Most of the time, we have a multiple convolution layer. Okay, after the after each convolution, we usually have a ReLU layer or a normalization layer and a pooling layer. These are the different layers that we have in the feature extraction. Okay, so we have the convolution, the ReLU, and the pooling. Also the normalization. Okay, we have many different layers. These are the layers that are used frequently. The most important one is convolution. After that, we may have ReLU, and we may have normalization, and one other layer is pooling. I will talk about these layers. Okay, I only talked about convolution. I only talked about convolution, which is the most important one. Okay, but the next one of the other layer that we may have is the ReLU layer. Okay, ReLU layer. What is the ReLU layer? A ReLU is doing a threshold on the output of the convolution layer. What does this mean? Threshold. In Farsi, threshold is حد آستانه. حد آستانه. Okay, let me explain about this threshold. Okay, look at this example here. Okay, this is the output This is the output of the convolution. Okay, this is the output of the convolution. Okay, for example, I put the threshold. I said that the threshold is threshold. Let me write it here. Threshold is equal to 0.1. Okay, threshold is equal to 0.1. Okay, when I say this, it means that the numbers that are equal to or less than this 0.1, they are put to 0, and the other numbers are don't change. Okay, the numbers that are less or equal to the threshold, they are put to 0, and the other numbers are not changed. Do you understand this? Yes, for example, here in this example, uh, this these two, this one, these 2 points, they are put to 0, and the other numbers don't change. Okay, the numbers that are less or equal than the threshold, they are put to 0, and the numbers that are higher than the threshold, they are not changed. Okay, so this is what happened in the ReLU layer. ReLU layer is putting a threshold on the output of the convolution. Okay, this is the ReLU layer. And the other layer is normalization. Normalization, it is normalizing the output of the convolution. Okay, means normalization means that the sum of the numbers are 1. جمع اعداد یک. The sum of the numbers should be 1. This is normalization. It means that the sum of the output inside the output, the sum of the numbers should be 1. جمع اعداد یک. For example, in here, in this example, جمع این اعداد یک. The sum of these numbers should be 1. This is normalization. It makes some changes to the numbers, so the sum of them is 1. Do you understand this? Yes. For in this example, the sum of the numbers are not 1. So what do we have to do? We have to make some changes. Okay, this is normalization. Okay, normalization does some changes on the number, so the sum of the numbers are 1. This is normalization. Okay, one point about this two layer, a ReLU layer and the normalization layer. This is very important. Okay, one point about these two layers. In these two layers, we don't have any weights. Okay, we don't have any learning in the ReLU layer or the normalization. Okay, we don't have any learning. It is just an operation. In the ReLU layer, we are doing an operation. In the normalization layer, we are doing an operation. We don't have weights. We don't have learning in these layers. Do you understand this? We don't have any learning in the ReLU layer and the normalization layer. We only have learning in the convolution layer. We only have learning in the convolution layer. Yes, I said that in this example, the sum of the numbers is not 1. Okay, so what do we do? What do we do? We have to change these numbers. And there are different methods. How can we normalize the data? How can we normalize the data? There are different methods for normalizing the data. Okay. Um, okay. Normalization means an algorithm for changing the numbers so the sum of them is 1. Okay. Okay, we have some formula. We have some formula to change the numbers so the sum of the numbers is 1. Okay, we have some formula to do this. Okay, so in the ReLU layer and in the normalization layer, we don't have any weights. We don't have learning. Okay, and the last layer that I want to talk about it here is the pooling layer. Pooling layer. Okay. What is pooling? Okay. After the convolution layer, pooling is a layer that it wants to reduce the size of the output of the convolution. Okay, the pooling layer wants to reduce the size of the output. That's why we use the pooling layer. Okay, Why do we need the pooling layer? Because we want to reduce the computation time. Okay, we want to reduce the computation time. That's why we use the pooling layer. Okay, so the pooling layer is a layer that it is after the convolution, and it causes to have to reduce the size of the output of the convolution. Okay, for example, if the size of the output of the convolution is this 32 by 32 by 12. Okay, for example, this is the size of the output of the convolution. Okay, what does this mean, 32 by 32 by 12? It means that we have 12 kernels. Okay, we have 12 kernels, and the size of the input is 32 by 32. Okay, I said that we have in the convolution layer we have some neurons. Each of the neurons is a kernel. Okay, for example, if the size of the input is 32 by 32. Okay, the size of the input is 32 by 32. The number of neurons in the convolution layer is 12. Okay, so the size of the output would be, for example, 32 by 32 by 12. Okay, the size of the output would be 32 by 32 by 12. Do you understand this? The size of the output. Okay, the size of the input is 32 by 32. Okay, and then we have 12 kernels, 12 neurons in the convolution layer. Okay, each of these kernels, they are doing the convolution operation on the input. Okay, so the size of the input is 32 by 32, and we have 12 neurons in the convolution layer. Each of these neurons are doing the convolution operation. Okay, and the output of each of these kernels is 32 by 32. So the size of the output would be 32 by 32 by 12. Okay, each of the kernels, when they are uh, when we are doing the convolution operation, each of the kernels, the size of each of these kernels is 32 by 32, and we have 12 kernels, so the size of the output of the convolution layer would be 32 by 32 by 12. Okay, let me see if I can find. Okay, let me show you something that helps to understand this better. Okay, can you see this? Can you see this, my screen? Okay. Okay, this is a example of the convolution. Okay, this is the and you see that each of these kernels, they are being moved on the input. They are moving on the input, and when they are moved on the input, each of them gives us a result. Okay, uh, and uh, you see here that, okay, in the input is blue. Okay, do you see it? The input is blue, and here you see that we have three inputs. Okay, we have three inputs because the image that we have, it is a color image. The image is a color image. If you remember, we said that the images, they are color images. Okay, most of the images that we have, they are a color image. In this example here, we have two filters. Okay, filter this one, filter W0 and filter W1. Okay, we have two different filters, and these filters, they are moving on the input. As I said, the reason that we have three inputs, because it is a color image. Yes, we have zero padding too. Thank you. Okay, we have zero padding. You see, around the input there is a zero. This is zero padding. The filter is moving on the input. Okay, and as you see, the number of input is 3 because it is a color image. Okay, also for the filter for these are two filters. This is filter 1 and this is filter 2. So we have two kernels. In the convolution layer we have two kernels, and these kernels, they are free. The first kernel, okay, you see, this is 1, this is 2, and this is 3. Why do we have 3? Okay, because the kernels, they are three-dimensional. Okay, like the input is a color, so it is three-dimension, and the filter or the kernel is three-dimension too. As you see here, there are the three different parts of the kernel is moving on the input. Do you understand this? The input and the filter, both of them, they are three-dimensional. Okay, because we have color images. The color image is three-dimension, and the filter or kernel, it should be three-dimension too. And here you see the output. Okay, the output. You see the output, it is green, and each of the numbers is created using the convolution operation. Okay, do you understand this? This is a good image. You can look at it. Okay, this is the I will paste. This is the address. Let me put the address here. This is the address, the link. This is the link of this web page. Okay, you can see it later. Yeah, this is the convolution operation. Okay, so here the input, the dimension of the input is 3, and the dimension of the filter is 3, 2. Okay, you see the kernel. uh, Okay, I said that here we have two kernels. W. Okay, okay. You say, why do we have two kernels? Okay, uh, this is this is something that we have to decide. Okay, we may have one kernel, but if we have more kernels, in the convolution layer, it means that we will have more features. It means that we will have more features. In this example, we have two kernels. Okay. Okay. Uh, yes, the input volume is a three-dimensional array. The input is a three-dimensional array. The input is a three-dimensional array. Okay. Okay, thanks. Have a 5-minute break. I will be back after 5 minutes. Thank you very much. Okay, do you have my voice? Okay. Okay, I want to talk about 2 points in the class. Please listen. Uh, uh, okay, one, if you have seen the in the Darsa site, if you enter the sorry, if you enter the course, you see that yes, this is the no, this is not. Okay, can you see my screen? Can you see my screen? Okay, you see here. This is a link I put for exercise 1. Some of the students have problem sending exercise 1. Okay, you can send it here if you can't send it in this link. This is the main link. Please send it here. If you can't send it here, send it in this link. Okay. One other point about the midterm exam. Midterm exam. Okay. We will have a midterm exam in 3 weeks. After 3 weeks. Okay. The midterm exam, the questions of the midterm exam, there will be some multiple choice question and maybe one question that you have to solve it, but most of the question are multiple choice. Okay, I will talk about the exam and the question in the next session. Okay, I will talk about the exam and the questions in the next session. Okay, in the next online session, I will answer your questions about the exam. But the time of the exam is in 3 weeks. In after 3 weeks. Okay, the time of the exam is 7 Azar. 7 Azar. Okay, هفته آذر 7 آذر sorry 9 آذر I'm sorry the time of the exam is 9th of آذر 9 نهم آذر I'm sorry okay نهم آذر 9th of آذر it is at and at 12 o'clock at 12 o'clock okay. This is the time of the midterm exam in 3 weeks, and but in the next online session I will talk about the questions. Okay, no problem. If you have any question, I will ask. I will answer. So this is about the midterm exam. Okay. The next point about the presentation. Okay, presentation. Here I have put something for the presentation. Okay, and here okay let me put it now. I haven't you can send the title of your paper. Okay, each of you can send the title of your Okay, your paper, okay, your paper should be from this journal. This is the name of the journal, Artificial Intelligence Review, and this is the link. This is the link. Okay, this is this is the website of the journal. Okay, you can get a paper. The year of the paper should be 2021. Okay, so you go to this website and you get a paper from this website, and the year should be 2021. Okay, but in this journal, if you want to get the papers, okay, if you want to get the papers, you can, for example, this is a paper. Okay, okay, you go to this paper and you can download it. But if you want to access the paper in the internet, there are some sites that you can access the paper free. For example, free paper, or there are different sites that because these papers are not free. Okay, you have to download them using some special sites. For example, freepaper.ir. Okay, there are some papers, or there is another site. This one, SCI-Hub. SCI-Hub. Okay, you can download the paper. Okay, if you have problem, I will talk about it in the next session. Okay, no problem. If you have any question about this, I will talk about it later. No problem. So this is 2 points about the presentation, and here in this if you enter the this link, okay, if you enter this link here, okay, presentation, okay, you should send the title of your paper. You click on this, okay, and then you can send here ارسال پاسخ. Okay, you can answer this and send the title of your paper. Send the title of your paper. Okay, in this here you can check if you want to send the title of your paper. Okay, here you can see the title of all of the students. Okay, in this link, okay, you can see the title of everybody, of every student. So check it is not repeated, it is not duplicate. Okay, here you can check it. Okay, if you have any problem about this, I will talk about it in the next session. Okay, thank you very much, and if you have any question, please ask. I will talk about the exam, and if you have question about the presentation, I will talk about it in the next session too. Thank you very much. Okay, thank you very much, and goodbye.